All right, here's a few more examples because I made the video in a hurry earlier so you guys would have it right away. All right, so the first one, we need to factor completely on the top and the bottom. So I have an x minus 2, so there's nothing I can do with that. There's an x minus 4, and there's nothing I can do with that. So we're kind of done there. So notice we have an x minus 2 and x minus 4. Because there is no factors that we can cancel from the top and the bottom, there will be no hole. So we put none. Okay, and then for the vertical, and remember from there, we're going to set the denominator equal to 0 and solve. So we set x minus 4 equal to 0, and we get x equals 4. And the vertical asymptote will be located at x equals 4. Okay, the horizontal asymptote, we don't know how to do that yet. So let's ignore that. It would be located at y equals 1, by the way. But we'll get back to that. And the zeros. So for the zeros, you set the numerator equal to 0. And we get x equals 2. And remember the zeros, we just list them out. We don't write the 2. All right, it's just a 2. And there's only one factor of x minus 2. So again, it's just a multiplicity of 1, and you don't have to write that. All right, for the y-intercept, recall that the y-intercept is just found by finding f of 0. So let's plug that in. Now, this not only is this the old function, but it's also the new one. So let's plug in 0 minus 2 over 0 minus 4. And that gives us negative 2 over negative 4. And that reduces to 1/2. So our y-intercept is 0, 1/2. Now for tonight, that's all you really have to do. But again, our ultimate goal here is that we will be graphing these. And these do get very complicated. So just to show you what all this looks like, the vertical asymptote will be x equals 4. So we would come over to 4. And we would put a dashed vertical line there. The zeros are located at 2. So there's a dot on the x-axis at x equals 2. And the y-intercept is 0, 1/2. So we'd go 1, 2 here. And that y-intercept is going to be right about here at 0, 1/2. And again, there's a lot more to do, like finding the horizontal asymptote. We might have to find a slant asymptote. There's a lot more we have to do. There's also additional points that we're going to need. Notice that this side of the graph, there's nothing over here. And we definitely need some points over here. So again, there's a lot more to do, but that's all you have to do tonight is to find the holes, vertical asymptote, zeros, and y-intercept. Okay, next one. Okay, looks like lots of factoring here. So I can pull out an x from the top, which leaves x squared minus 9. No, that's not done being factored. And the bottom. All right, so, oh, it looks like a 3 comes out. That makes it a lot easier. And then x squared minus 2x minus 3. All right, and I don't have enough room there. All right, so we have x. This is x plus 3, x minus 3. And on the bottom we have a 3, and you can't forget all this stuff. And we have an x minus 3 and an x plus 1. Okay, I think this is a plus. All right, now, for the holes, you immediately need to look at any of these and look to see what cancels. So if this cancels, there will definitely be a hole. All right, now I need to write that new function, and I'm going to write it up here so we have it, of x plus 3, and on the bottom we have a 3 and an x plus 1 still. And then I'm going to write f sub n for new of x. Okay, so there's our new function. After we factor and cancel out the factor that makes the whole. Everything else will be found from this. You don't really need to go back and look at the other one. Now, when we talk about horizontal, we might need to look at that one a little bit, but all the calculations we're going to make, we just do from the new one. All right, so let's do the whole. All right, so the canceled factor was x minus 3, so I'm going to set x minus 3 equal to 0, and I get x equals 3. And again, that's just the x value of the whole. So I write that down. And now I have to find the y value. So the y value is going to be f sub n of 3. And just plug that in. And again, into the new function. So we have 3 over, or no, 3 parentheses, 3 plus 3. A lot of 3's on the top there. On the bottom, I have this 3. And then I have 3 for the x plus 1 there. All right, let's see. I have 3 plus 3 is 6 times 3 is 18. On the bottom, we have 3 plus 1 is 4 times 3 is 12. And reducing that by a factor of 6, looks like we have 3 halves. Okay, so I just found f of 3 in the new function, and we got 3 halves. Now the wholes always don't always have a fraction there, but a lot of them seem to at this point. And that's okay. Okay, what's next here? Vertical asymptote. So the vertical asymptote, you just take the denominator. Whatever factors in the denominator, set that equal to 0. Now, since 3 cannot equal 0, we're going to ignore that. Now, when we get to the zeros, we're not going to ignore that x right there because it's a variable. But I don't need to set 3 equals 0 because 3 is never equal to 0. So I'm only going to set the x plus 1. Anything with the x's, I'm going to set equal to 0. And I get x is negative 1. And I put x is negative 1. You need the x on this one because, again, you're finding the equation of a vertical line. And the equation of a vertical line is x equals number. And there it is, x equals negative 1. Okay, again, we're going to ignore the horizontal asymptote for now and find the zeros. For the zeros, let's see. Let's do that over here. Zeros. We are going to set the numerator equal to 0. Since the numerator has this x out in front, we're going to set all of this equal to 0 then. And I'll just show you. I can write it all out. Oh, that's a 3. Equals 0. And then now we cannot forget this x. We're going to set all factors that have an x equal to 0. And notice that there's nothing to do with this one. I'm just going to rewrite it. Oh, I forgot to set that equal to 0. And we get x is negative 3. So this one actually has 2 zeros. That's okay. You can get multiple zeros. Just like our polynomial functions, we had 3, 4, and 5 zeros. That's not a problem. So we have a 0 and negative 3, and they're both multiplicity of 1. So we're just going to list them out. And again, most of these just have a multiplicity of 1, and that's okay. Okay, there they are. Then the y-intercept. And again, with the y-intercept, just plug in 0 into the new function. So I'm finding f of 0 in the new function. So I have 0. Oh, well, again, this makes sense. I see what's coming here. So 0 and 0 plus 3 over 3, 0 plus 1. Well, I have 0 times something, so that's going to give me 0 on the top, and 3 times 1 is 3, which is just 0. All right, so there's something interesting here, and we have to figure this out, and I'll show you what's going on here. All right, let's see. All right, so I went and just cleared all that out of there, just to get it out of our way. All right, you see that? You probably see that little box going around, but that's okay. I don't feel like doing anything with it right now. All right, so what do we have? Let's see. 1, 2, 3, 4. Okay, so the hole. The hole is located at 3 3/2. So we go to 1, 2, 3. We go up to 3/2, which is just 1/2, 2/2, which is 1, and 3/2, which is right about here. And we put in open circle for the hole. And I'll try to show you what this graph looks like a little bit, at least maybe on one side, if I can, depending on how much information we have, because I haven't done the horizontal asymptote. All right, so the vertical asymptote is at -1. So we go to x equals -1, and we draw a vertical asymptote. There it is. All right, we have zeros at 0 and -3. So there is a 0 here. I don't like putting that on black. Let's make it blue. So there is a 0 here. And there is a 0 at -3. 1, 2, -3, which is right here. All right, now look at the y-intercept. Now we ran into this on the polynomial equations where if we found a 0 on the x-axis at 0, remember it also touches the y-axis. So this makes complete sense that we found the, well, I can't put a check there for some reason, that we found the, can I not write over here? Okay, I can write here, fine. Something's going on with it. I don't like it, but that's okay. So we found that the y-intercept was also 0, 0. So that makes complete sense. Now, let's see. All right, I'm trying to figure something out up here. All right, this is not a good graph to try to imagine, but the graph is somehow going to come here. There's just going to be this slanted asymptote thing on this problem, which is going to cause us issues that I don't want to get into right now. But the graph is basically going to go from this point and kind of come through this point, right? And then skip over it and then keep on going. So we're just going to have a graph that kind of comes up to it, has a hole, and keeps on going. That's okay. I'll show you using our graphing calculator why that occurs tomorrow. That's not a big deal. For now, again, just plot everything that we did. You don't have to make a graph, but it's kind of nice to see that, just to make sure that you can if you want to. And don't worry, we will be doing this all tomorrow. All right, 2 more examples here. All right, factor. All right, this looks like it's going to take a couple of steps maybe. So when I see we can pull out a 3x on this one, make sure you get everything. So we have a 3x, and this would give us an x minus 4. (3x squared minus 12x). Yeah, okay. On the bottom, this factors into x minus 3 and x plus 1. All right, so there's lots of factors here. We have a 3, an x minus 4, an x minus 3, and an x plus 1. Nothing matches. If nothing matches, there will be no hole. None. Not a problem. Okay, so then this, since nothing canceled, this is going to be our new function right here. It's just the old function, but just in factored form. Okay, vertical asymptote, just going through. So we have to set everything down on the bottom equal to 0. So I'll just write it out. X minus 3, x plus 1 equals 0. And that means that this is going to be equal to 0. And this is going to be equal to 0. So we have x is 3 and x is -1. So for vertical asymptotes, there's going to be 2. And I'm going to list them right next to each other. And again, you have to have the x equals -1. There we go. Okay, so there's two of them, and we're not going to do the horizontal for now. For the zeros, set the numerator equal to 0. So I'm just going to go ahead and set the entire thing equal to 0. And if you haven't figured it out already, you're going to have to memorize a lot of this stuff. You're going to have to make sure that you know what to set equal to 0 and what to cancel. On a quiz, there's going to be no indication on how to do that. Hey, Mr. Manning, what do I set equal to 0 to find the 0? Well, you're just going to have to figure that out. So the more you do, the more you practice, the better you're going to get at this. All right, so again, I'm going to set each of these factors. Now, this is all multiplication. It's 3 times x times this. But I'm not going to set this factor equal to 0 because there's no way a3 is going to be equal to 0. But I will set that one equal to 0. And I get that. And then I have x minus 4 equal to 0. So I have two zeros as well. And I get x equals 0 and x equals 4. So I have a 0 and a 4. Now that automatically tells me that the y-intercept is going to be 0, 0. And you can do that by plugging in a 0 here. This would give you 0 in the numerator, and the bottom, who cares? And you're going to get 0. If you have 0 in the numerator, it's going to cause that to be 0. So there you go. If you want to see what that would look like, quick. Let's see. So vertical asymptotes at 3. 1, 2, 3. Draw a vertical line with the dash. X equals -1 here. Draw a vertical line. Now this is not actually part of the graph. These are the lines that will help us to graph. 0 is at 0, which is also the y-intercept, and 4. So 1, 2, 3, 4. Which is about here. And the y-intercept, which we already graphed. Okay, next one. Let's factor. And again, make sure you're always looking for a GCF just to make the factoring much, much easier. Okay, we have an x squared plus 5x plus 6. And it looks like we should get something that cancels, I believe, from the bottom. Okay, the bottom then, x plus 2, x plus 1. And then I still need to factor the top a little bit into x, let's see, 3 and x plus 2. That's a plus, and that's a 1. All right, so we have a factor of x plus 2 and a factor of x plus 2, so we will definitely have a whole. And before I do that, I'm going to write the new function, which you should be doing every single time. If you don't, you're going to be getting lost. And you're not going to be having much fun graphing these things. Okay, so there's our new function. So now we're going to locate the whole. And again, the x value of the whole is found by setting the factor that you canceled equal to 0. And we get x is -2. So then I come up here and say -2 is the x value. Now we have to find the y value. And just plug that -2 right back into that function. All right, I had a little boo-boo, so I had to edit a little bit. So it seems at this point we're okay. I found the x value was -2. All right, let's see here. All right, so now we take that value and we plug it into the new function and we plug in -2. All right, what I did on my original take is I plugged a +2 instead of a -2, so I messed up a little bit. And what happened was it didn't agree with the rest of my graph, just like the polynomials. Something didn't agree, and I didn't like it. I'm like, man, something's going wrong. So I went back and checked everything, and that's what I found. And that's why I'm always checking things at each step, just to avoid some extra work when we make mistakes. All right, so hopefully this one's a little better. All right, so we have negative 2 plus 3 is 1, and 1 times 2 is a 2, so I get a 2 in the numerator. And negative 2 plus 1 is a negative 1, so that tells me negative 2. Now a negative number here is much better, because the other one I got a positive number, which didn't make sense with the rest of the graph. So it's negative 2, negative 2. And I can also show you what the one side of the graph is going to look like now, because I wanted to do that on that previous problem, but I ran into a problem, and that's why I cut. All right, so it looks like we, in the other video, I had already found the 0, so I have not found it in this take yet. So let's do that. So for the 0, we're going to set the numerator equal to 0, and that's right here. So we have 2x plus 3 equals 0. Now when we have an equation, we have a factor that's not an x, we ignore it, and we're just going to set x plus 3 equals 0, and x is negative 3. And there we go. I have a 0 of negative 3, which I had already written right there. And then we also need to do the y-intercept, it looks like. I don't think I did that one in this take. Yeah, it's blank right there. Anyway, so let's do that. So we're going to, in the new function, we're going to find f of 0. So I have a 2, which I can't forget, and I have 0 plus 3 over 0 plus 1. And it looks like we get 6 over 1, which is 6. So I have a y-intercept of 0, 6. All right, let's see what this graph looks like. So I'll put that out. I will put in some all the stuff that we need. Okay, whole at negative 2, negative 2. I'll do all this other stuff in red. So negative 2, which is about here. Vertical asymptote at x equals negative 1, which comes right down through here. Perfect. And I have, let's see, a 0 at negative 3. 1, 2, 3. Right here. And I have a y-intercept of 0, 6. So 0, 1, 2, 3, 4, 5, 6 up here somewhere. Let's make this 5. So I have it right there. Okay, what you don't see and what we cannot calculate, the horizontal asymptote comes from the leading coefficients. So I'm not going to teach you what I'm about to do, but because the degrees here are the same, I'm going to look at the coefficients, and it's 2 over 1. So I know I'm not really explaining anything, but I'm telling you the horizontal asymptote is going to be the line y equals 2. Now I'm telling you this because I want to show you what this graph is going to look like a little bit. So let's get that horizontal in there. And again, we're going to learn more about this tomorrow. All right, now I'm going to graph everything in blue. Well, this is what it's going to look like. The graph is going to come up here. It's going to start approaching this asymptote. It's going to get closer and closer and closer, but never touch it. And then it's going to come down here. It's going to hit this hole looking thing, and then it's going to skip over it and then keep going down over here like that. And the other side is going to look something like this. Now we would need additional points to get a better idea what's going on, but it's going to look something like this. I just want to show you what one of these graphs is going to look like. And this graph should look very familiar to you because we already did rational functions with our parent graphs earlier in the year, but we didn't worry about holes and and all kinds of stuff going on back then. We didn't worry about that because we didn't know about it yet. But now look, does that should look like your parent graph. It wasn't the last one, maybe the next to the last one, with the y over or y equals 1 over x function. It looks like the reciprocal function. But it wasn't as complicated as this. It didn't have holes and things, and we didn't have to worry about that. So that's what that graph is going to look like. Don't worry about that you didn't know how to calculate the horizontal asymptote. It's actually kind of a long procedure that you have to do in testing it, but that's what it would look like. All right, hope that helps. Hope the videos earlier helped today, and make sure that you're doing the problems. So for each one, again, all you're doing for these, you don't have to worry about the horizontal. All you're going to be doing are the holes, vertical asymptotes, zeros, and y-intercepts. Get that done, and then tomorrow we're going to learn about horizontal and slant asymptotes, and then we're actually going to begin graphing these things. And we're going to be graphing for a couple of days because these require some work and some practice. Alrighty.